Alright, so welcome to your third installment of Reducing Radicals with Coach Chandra. If you'll notice here, what we have is our radical with a fraction in here. And what's interesting to note about this is that with a fraction, I can actually separate the radical because I was able to combine them with multiplication in the earlier lesson. I think it was lesson 1. I can also separate them with the division. So anytime I see this, I can rewrite it as the square root of 25 divided by the square root of 36. So from here, I know that the square root of 25 is 5, and that the square root of 36 is 6. And so this ends up being my final answer of the square root of 25 over 36. Pretty easy. Now, on the second one, you'll notice that these are not nice numbers. So what I'll need to do is I'll actually need to use my factor tree again. So 500 splits out to 5 and 100, and 100 is 10 and 10. And since I know I have a pair right here, I can actually stop doing what I'm doing right there and rewrite it as the square root of 5 times 10 times 10 divided by the square root of 5, since 5 doesn't really have much going for it. So I have my pairs here, and I can highlight them for you. There's my pair. So when these guys come out, only one is going to remain. So this is going to be rewritten as 10 square root of 5 divided by the square root of 5. Now, if you'll notice, these two numbers right here are dividing themselves. What is one number divided by itself going to be? 1. So these will actually end up canceling each other out, or just turning into the number 1. So I'm going to cancel this out, and my final answer to all of this is 10. Alright, so what I would like for you guys to do here at this point is go ahead and pause the video and attempt these two problems for yourself and see how good you are. Alright, so the answers you should have gotten were the square root of 36 divided by the square root of 16 is equal to 6 over square root of 16 is 4. This can be reduced even more. What can both of these divide by? I can divide both by 2. So that reduces down to 3 over 2. Alright. Wow, 147. What does that divide by? Let's see. So y'all want to know a cool trick? If I add all these numbers up and the number is divisible by 3, then I know I can divide by 3. So 5 plus 7 is 12, and 12 is divisible by 3. So I know 147 is also divisible by 3. So let's check it out. 147 divided by 3 is 49. Awesome. So 3 and 49, 7 and 7. So we end up with the square root of 3 times 7 times 7 divided by the square root of 3. And so I have my pairs right here. And so these two are going to come out, and only one will remain. So 7 square root of 3 divided by the square root of 3. And again, those cancel, and so my final answer is 7. Alright, so this next one's going to be real fun, and by fun, I mean probably the most challenging in all of this, which is called rationalizing denominators. So when we rationalize denominators, if you notice in any of these fractions, we never had a radical in the denominator, and we don't intend to start doing that right now. So the way I'm going to eliminate this is by manipulating my numbers. Now, what happens to any number when I multiply it by the number 1? So let's say 3 times 1 gives me 3, and negative 7 times 1 gives me negative 7. So anytime I multiply by the number 1, I get that same number back. So it's safe to say that if I were to multiply this by the number 1, I would still end up with 3 square root of 5 divided by the square root of 2. But just multiplying it by the number 1 doesn't change the way it looks. So I have to find another value that is 1 but doesn't look like the number 1. So in this case, I'm going to use the square root of 2 divided by the square root of 2. And if you notice, you take the same number and divide it by itself, that equals the number 1. Okay, so just as a little reminder there in red. So why am I doing this? Well, remember that when you're multiplying square roots, you can multiply them within themselves. So in other words, 3 times the square root of 5 times 2. These two guys can multiply because they're underneath the radical sign. So here, in the division, I can do the square root of 2 times 2 as well. And what that does, what this will end up doing is, if you notice, you have your pair right here now, which you can come out. Or you can look at it this way. What is 2 times 2? 4. So what's the square root of 4? 2. So, moving down here so you can see it a little better, this gives me 3 square root of 10 divided by 2. And if these two numbers were both divisible by each other, I would reduce these down even further. But since this is a 3 and a 2, I can just leave it as 3 over 2. So, moving on to the next one. Alright, so if you'll notice, the square root of 8 is actually something that I can reduce. And if I look at my factor tree here, what is this? 8 gives me 2 and 4, and then 2 and 2 again, right? So the square root of 2 divided by the square root of 2 times 2 times 2. Just to reiterate our first lesson here, we have a pair. So when that comes out as a 2, right? So this is going to give me the square root of 2 divided by 1, 2 to the square root of this leftover 2 right here, 2. And if you'll notice here, what's nice is that even though I have a square root in the denominator, the numerator is carrying that exact same square root. So I can actually cancel them. Now, what's left over though, the top doesn't stay blank. What invisible number do you guys remember being here? Should be the invisible number 1. So when this becomes eliminated, the 1 is made visible. So my answer is 1/2. Alright, so last slide for today. And this is going to be the time where you guys would take the opportunity to try these out on your own before I see you guys tomorrow. So go ahead and pause it and take a moment to do that. Alright, well, I hope you guys worked hard at these two problems, and let's see how you did. So remember here, both of these I can't reduce down anymore, so I'm going to go ahead and try to get rid of the square root out from underneath the denominator. So the number that I need to multiply is the number 1, but the way I'm going to do that is the square root of 7 divided by the square root of 7. So this gives me 3 square root of 5 times 7 divided by the square root of 7 times 7. And so here you see that pair happening again, that comes out. And so my reduction gives me 3 square root of 35, because 5 times 7. And then this comes out as a 7. And again, since these are not reducible, these two numbers right here, I'll leave them alone. And then lastly, I can reduce 10 down to 5 and 2, which doesn't get me any pairs. So what I'll need to do then is multiply this by the square root of 10 divided by the square root of 10. So I end up with 5 times the square root of 10 divided by the square root of 10 times 10, which there's my pair that I'm looking for that comes out. And so this is also equal to 5 square root of 10 divided by 10. Now, I've been saying that these two numbers were not reducible, but now I'll notice that 5 and 10 are. 5 divided by 10 reduces to 1 square root of 10 divided by 2, 1/2, right? And if you want to, you don't have to put the little 1 there. Remember, it's an invisible 1. So my final answer for this would be the square root of 10 divided by 2.